So Emma is doing a similar pattern, but she's going to start with 5 tiles in the middle. She thinks that her expression is going to be 5 times b minus 1 plus 10. Is she correct? And explain your reasoning. Oh, Leah.
I said no because in this case her border would be 12 tiles and his was 10, so that would work.
Okay, so the constant's going to be different, is what you're saying. So yeah, if she's got 5, then you're going to have these that I have in green are going to be your colored tiles, and that is an addition of 12 is the new constant. Okay. What about the 5 times b minus 1? Why do you think that's not going to be the same?
Because of the way it doubles, it still adds on 4 on each.
Right, it's still going to add those 4 corners each time. So what should Emma's new, well, actually, we can kind of get in that. Is Emma's statement correct? Explain your reasoning. 12 is going to be the new constant, and we are adding 4 corners times b minus 1 rows. So then the last question says, if Emma starts with a row of n number of tiles. So this is connected, but not exactly the same. So n number of tiles. We don't know how many tiles. If she starts with n, what should the expression for all the border tiles be? Well, let's think about it. When we had 4 tiles in the middle, how many did we end up in?
Can you repeat that question?
The question that's written or my question now?
Your question.
My question now is going to direct you, and I'm trying to figure out if I want to ask it yet. So what's been the easiest thing to figure out so far? The constant, yes. So when I had 4 tiles in the middle, my constant was how much? 10, right? That was my constant. When I had 5 tiles, my constant was 12. If I have, well, we don't know this, but if I had n number of tiles, what's my constant going to be? How am I getting from 4 to 10? How am I getting from 5 to 12?
Or n times 2 plus 2.
Say it again.
N times 2 plus 2.
N times 2 plus 2. So you're saying take that number, multiply it by 2, and add 2. Is that right, guys? Times 2 plus 2. So if I take n times 2 plus 2, that gives me, how would I simplify that as an expression? 2n plus 2. Now, is that the whole expression? No, that's just the constant. So this much is the constant. How do I show the rest of that pattern? If these are just the very top, the very bottom, and the 2 ends, how do I show the rest of that pattern in an expression? So close. This is my constant border tiles. How do I show the rest of it? 4 times what? No. Not 4 times the constant. The constant is constant. Would I still put B?
You said that the constant, the equation down there, the constant is the
No, this is just the constant number of tiles. So like the ones that are at the very top and the very bottom and the two on the ends. But like if I go back, it would just be these for n number of tiles. But how do I account for all these other ones that were going to be on the ends?
Is it 4 parentheses n minus 1 plus 2n plus 2?
Not quite, no. This is my constant, so this is the part that's at the end. 2n plus 2. How are, yeah, because this is the constant part of the expression. What's happening as this gets bigger? Is this not the same kind of pattern as was for Fred and for Emma? How did we show not adding 4? What'd you say? Yeah, 4 times b minus 1 again. It's still adding 4. You said 4n.
Well, that's the same.
No, it's not. I don't think so.
The number of tiles.
4 times b minus 1 plus 2n plus 2.
They wouldn't be the same number?
No, I don't think so. So, if I had, oh jeez, you're gonna make me prove this now? Ooh, so if I have border 2, let's try it. If I have border 2, that's 4 times 2 minus 1 plus 2 times n is a row with n number of tiles. In border 2, I have 1, 2, 3, 4, 5, 6 tiles. 2 times 6 plus 2. So 4 times 1 is 4, plus 12 plus 2 is 18. No, 12 plus 2 is 14, total of 18. If they were the same, it would be 4 times 2 minus 1 plus 2 times 2 plus 2, which is 4 plus 2 is 6, which is 10. So they are not the same. So, but you are using the exact same method as you did, as I said, with Fred and Emma. So that's why that part is 4 times b minus 1 plus 2n plus 2 is that in simplest form. Is that in simplest form? We should distribute, yes. So if we have 4b minus 4 plus 2n plus 2. And I can simplify my numbers here. So the final answer is 4b minus 2 plus 2n. For n number of tiles in the middle, adding it in that same similar pattern where b is going to be the border number. Okay? Yes?
Doesn't matter which one you think.
You mean like, can I put 2n first? Yeah. No, it doesn't matter. So I could have 2n minus 2 plus 4b, something like that. Okay? All right. Now that your brain is like fried, let's go to page 18. I think you'll find these a little bit easier. We are only doing the top 4. So here we're trying to figure out page 18, the page right before. Are these two expressions equivalent or not? So I want you to take about 4 minutes and figure out, are they equivalent or not? Probably less than 4 minutes. Come on, Floyd. You can do it. Take a look at them. Are those two expressions equivalent? And I will tell you, some are obviously easier than others.
No. What? A plus time?
Distributive property, an algebra teacher's favorite property. Is there only one strategy that'll work to check these? Do you think there's only one?
No.
No. You're right. There's probably at least a couple, at least two. All right. Are we ready to rock and roll? Or you want a little bit more time?
A little bit more.
Okay. Let's see. I would say the number 4 is the easiest one. The fourth one is probably the easiest. Then maybe the first one would be the second easiest. The middle two, All right. So let's take a look at the first one. A plus quantity 3 minus B. Is that equivalent to quantity A plus 3 and quantity minus B? How many say yes, it is equivalent? Ooh, not many, not many. About 3.
Wait, what'd you say? Sorry, we were trying to say we got the same thing.
Okay, I said in the first problem, first example, are those two expressions equivalent? Yes or no? Yes? Okay, there's a few more. How many say no, you're pretty sure it's not? Okay, so I need people to help back it up because you can't just say yes and no, you got to say why. So people who thought they're equivalent, why do you think they are equivalent?
Because you can't distribute
You're right, we're not distributing here, but I don't know that proves it one way or another. Huh? You're not distributing it. It is a minus B, but you're not distributing it. They're not the same. You said they were equivalent?
No, they are. Yeah.
You are. They are. Yes. You're saying yes.
3 and B is not the same, so you can't like simplify it together.
Right. To a point, yes. To a point. Okay, so I don't hear a lot of strong sides there. Those of you who said they're not equivalent, why do you think they're not? Look at it. Does that look equivalent to you? Doesn't to me. No, I need a little more than just look at it. Yes.
So I didn't solve it to get an answer. I just set it up as both of them up as an equation. It wasn't the same thing. So I did the A into 3 minus B, and then I moved the negative B into 3 and A, and they got like 2 different names.
Results?
Yeah.
Okay. So what did you do for A?
So I'll put the A into the
A into the 3. What do you mean?
Like, multiply.
You multiplied?
Distribute.
Okay, but we're adding. You can't distribute. I mean, if it was A out front, yes. But this says A plus. So I'm going to say that's not going to work. So let me interject. Or yes.
I said,
Bea, what do you say?
I said yes, but the way I did it, I gave the letters numbers. Like I said, A equals. Oh, you said Bea.
I did,
I'm
but.
so sorry. Tell your things.
What if they, I mean, like, this makes me good, though, but like, they would have to be the same value for the equation to be equivalent, because if whatever the values of either number are, if you, I don't know how to explain it, they would have to be the same number to be equivalent, I think.
What would have to be the same number?
A and B,
A and B would have to be the same number?
I think.
All right. So I'm going to put this all together because we need to keep moving on. So, all right, last word.
Doesn't it?
Do you think they are equivalent or not, first of all?
I haven't made up my mind. I said something at first and I changed it, but
Okay.
This is the thing I was gonna say. Does it not matter, like, what is the word? Like, when you're adding and subtracting, it doesn't matter what
Sometimes it's a little tricky because there's parentheses here.
yeah, that's what I'm saying. I thought it was not equivalent because when the order that you have to add and subtract,
Yeah, order of operations is definitely a thing. Yes. However, let me follow up with what Leah started to say and kind of what Vea was saying also. So one way to check some of these is to actually substitute in values. Substitute in values. This is not what I would recommend first, so why am I writing it first? I don't know. I shouldn't have said it first. But because they said it, I think that's why I'm going with it for right now. So let's say A is equal to, 8. And B is equal to 2. So if that's true, this would be 8 plus, parentheses, 3 minus 2. Is that the same as 8 plus 3 minus 2? So here I get 3 minus 2 is 1, 8 plus 1 is 9. Here I get 11 minus 2 is 9. You're like, okay, so it works for that one. Does that mean it's going to work for every number for values of A and B? Not necessarily. So if you choose to substitute values, you should try substituting at least more than one. Okay, so you should try another set of A and another set of B's. Maybe include a negative or 0, okay? At least choose more than one substitution. Does that make sense? So that is one definite way to do it. Now, is there a way that we can change subtraction to be addition? Is there a way we can change subtraction to be addition? If I said 8 minus 3, how could I write that to be 8 plus something?
How does that number be negative?
Being the negative. So let's see if I change my subtraction to be adding the opposite. Then I would say A plus, instead of 3 minus, I'm going to make that plus a negative B. I'm still going to keep it in parentheses for now. How does that compare to A plus 3 in parentheses and change this minus to plus a negative B? Now, what you may or may not remember, and you know this, but you don't maybe know the property, addition is commutative. You can change the order. 5 plus 4 is the same as 4 plus 5. So it doesn't matter if it's in parentheses. If you are adding all of these together, it doesn't matter what order you do first. So the end-all answer here is yes, these are equivalent. Nobody's like, yeah. Okay. So algebraically, you can change that subtraction to adding the opposite, or you could substitute in a couple of different values. Questions on that one? All right, let's go to the next one. 2 plus k divided by 5 and 10 plus k. And you've got to be able to back up your answer. You can't just say, well, yeah. Well, no. So what do we think? Equivalent or not? Not equivalent? Not? Anyone say yes? How do you know? How do you know? What did you do?
I did the substitute again.
Okay, so she substituted. What did you put in for k?
2.
Okay, so this is 2 plus k is 2/5, or k is 2. And how does that compare with 10 plus 2? Well, obviously this is 2 2/5, and this is 12. If you're going to substitute, you should check with another value just to be on the safe side. And if you pick another one, maybe even a negative, let's say a -1, 2 plus -1/5, how does that compare with 10 plus -1? Well, here you're going to get 1 4/5, and here you're going to get 9. So this seems to be not equivalent. But does anyone know how to show that algebraically? When you are dealing with a fraction here and you are adding it to a whole number, what do you have to do before you add fractions? Say it again. Okay, so I put it over 1, so I can add these as they are now. I need a common denominator. What is my common denominator here? What? Yeah, it's 5. So if I want to change this to a 5, what's my new numerator going to be? 10, because you're multiplying by 5 over 5, which is really 1, right? A form of 1. So this is 10/5 plus k/5. Is that equivalent to 10 plus k? Well, you can put those together and say 10 plus k divided into 5 parts. Is that the same as 10 plus k?
No.
And it is not. So that's how you can prove that algebraically. Questions on that? Okay, guys, come on, heads up, heads up. I know this is tedious. This is real math work. This is critical thinking. Okay? Critical thinking. All right, so the next slide. Okay, this is going to separate the Algebra 2 people from the people that maybe didn't quite learn it the right way. So we have quantity a minus b, quantity squared, and a squared minus b squared. Are those equivalent or not?
3 on 3.
I heard yes and no.
Yes.
Yes and no. How many say yes, they're equivalent? How many say no? Ooh, just one. Talon, tell me why. Can you back it up?
All right.
Huh?
All right, no, I can't.
Not right now. How about in a minute? No? Let me ask you something. If I say 3 squared, what does 3 squared mean? Don't give me the answer. What does it mean? 3 times 3. So if I say a minus b, that quantity squared, what does that mean?
That means that
A minus B.
That's the Pythagorean theorem.
No, it's not Pythagorean theorem.
No, she didn't.
Now, if you double distribute, you're going to look something like this. For the first one, you get a times a is a squared. A times negative b is negative ab. On the underneath, negative b times a is another negative ab. And negative b times negative b is plus b squared. So if you simplify, a squared minus 2ab plus b squared. Is that the same as a squared minus b squared? It is not. You guys forgot how to do that. Lots of times you guys are thinking of, taking the exponent, and when we're multiplying, yeah, that's a squared b squared. But when you have an operation in here, you can't do it that way. So this is not equivalent. Okay. And the last one, I think this one's probably the easiest. 3 times quantity z plus w and 3z plus 3w. Equivalent or not?
Yes.
Yes. Why? Distributive property. Yes. This is where you can say 3 times z plus 3 times w, and that is equal and equivalent to that. Okay? All right. So that ends our lesson for today. However, we do have homework. So your homework is on Canvas. It is homework number 2, making models to fit patterns. It is actually that second half of the page 18. So if you want to finish doing those problems below and work it out below, you do have to submit and just put your answers in on Canvas. Okay? Does everybody understand what I'm saying?
Yeah.
All right. Yes. Are we having a test next Friday? It is the 25th. Yes. Test next Friday. I will give you a study guide on Friday. You can start looking at it over the weekend, and we will be working on it at least a couple of days next week. Okay? Marion, did you have a question? When is it due? Usually whenever I give homework in here, I'd like it to be due the next day, but as long as you get it done the next day, 2, 3, you're fine. And I am trying to get some grades in, so I need to do a lot of grading tonight. All right, expressions, simplifying. What? No, we're not. Although, I got a joke. You ready for the joke? I'm going to include the joke here. I am videotaping and recording this, so keep it clean. Why was the calendar afraid to die?
Because it had too many dates.
Close. That's what I said the first time I heard it. Something about lots of dates.
What was the question?
Why was the calendar afraid to die? No fair looking it up. Huh? No. Because he knew his days were numbered. I'll be here all week, everyone. Thank you. Thank you very much. Thank you.